So you have learned how to create generic classes. Now in this generic class, we have a couple of generic methods, add and get. But we can also declare a generic method inside a non-generic class. Let me show you. So let's add a new class to this package. We're going to call it utils. This class is going to have a bunch of utility methods. Now, let's say we want to get the maximum of 2 values. So here we can add a public method. We make it static so we don't have to create an instance of the utils class. This is a common convention for declaring utility methods. We make them static. Now we return an integer. We call the method max and give it 2 parameters, first and second. Here we can use the ternary operator to return the maximum of these 2 values. So we return, here we have a Boolean expression. If first is greater than the second, we return first, otherwise we return second. Pretty simple, right? Now, we want to make this method generic. So instead of getting 2 integers and returning an integer, we want to be able to work with different types of objects. Now, we don't necessarily have to make this class generic. We can declare a generic method inside a non-generic class. Let me show you. So just before the return type, we add the generic type parameter, okay? Now we replace all these integers with t. So here's the return type and the 2 parameters. We have a compilation error because we cannot apply the comparison operator between objects of type t. We can only apply it to numbers and characters. So how can we compare these 2 objects? Well, you learned about the comparable interface in the last video. So here we can tell the Java compiler that this t is an object that implements the comparable interface. How can we do that? We type extends comparable of t. So we're applying a constraint. Now, when we type first dot, we see that this object has a method called compare2, which takes an object of type t. So we can compare first with second. If it's less than 0, then we're going to return second. Otherwise, we're going to return first. So this is one application of the compare2 method. Now let's test this method. So back to the main class. Here we type utils dot, we call the max method. Now look at the type of this parameter. It's t, because at this point, the Java compiler doesn't know if we're going to pass an integer, a character, a string, a user object, or what. Now, the moment I pass a value here, let's say 1, the Java compiler knows this is an integer, so it wraps it inside the integer class, and it knows that the second parameter should also be an integer. So I cannot pass a character or a string here. This is the benefit of using generics. Instead of adding 2 parameters of type object, we use a generic method, okay? Now, back in the main class. So let's pass 3. This will return the max. We store it here and then print it on the console. So the max is 3. Now we can also pass 2 user objects. So let's say 1 user with 10 points and another user with 20 points. Obviously, the return type of this method is now going to be a user object. So when we print it, we get this long string, which includes the fully qualified name of the class, followed by an @ sign, and then a hash code. I talked about this in the previous parts of this series. So when we pass an object to the printline method, the toString method on that object gets called. So that long string that you saw returns from the default implementation of the toString method. To solve this problem, we go back to the user class and override the toString method. So first we apply the override annotation. We're telling the Java compiler that we're overriding one of the methods inherited from the base class. And then we type public string toString. Yeah, here we can return a simple string like this. Points equals plus points. Now let's run the program. So you can see that the user with 20 points is the maximum of these 2 user objects.